Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and this is an announcement, by the way. So, I've been working on a series of 8 lessons which will teach the educator, the math educator, or the math professor. Here are the lessons: how to teach fractions, okay? And I've done them both in Greek and also in English. Now, I'm in the process of trying to find professional presenters, video presenters, because I'm really not good at presenting stuff. As you all know, I tend to go off on tangents and sometimes I go into a bit of a rant, but this is done so well. It's done so completely. It's exactly how a kid is supposed to learn about fractions and numbers and everything. And it starts right at the beginning and goes all the way from geometry into algebra. So let me give you a quick idea of what this looks like. I'll get rid of the camera now. So the first lesson will be on measure, and it's this guy here. And what we're doing here is we're looking at y ratios, how to represent the ratios, examples, and then in the next lesson, which goes on to this guy here, which is lesson 2, and it's georithmetic. Okay, so georithmetic will teach you how to do subtraction, addition, division, and multiplication without numbers, just using ratios. Okay, and so when you do that, you have to apply something from the previous lesson, right? And the previous lesson tells you that you can only work with these if they have the same consequent. So you'd do something like this, something like that, and wow, now the proportions are the same, okay? And of course, the fractions are in proportion, okay? And now you can get rid of that and see how easy it is to do the subtraction, the addition, the division, and of course also the multiplication. And then there'll be a next lesson in which we'll see how to find a common line segment that fits exactly. Okay, and that would be lesson 3. That's counting in units. That's why you need to find a common line segment. And that's what this lesson is about. So you get a method. This is the method. Very easy, isn't it? You take the difference between the two lines, making the second line first and the difference second until the last difference is the same as the previous line, and you go through the entire process. Then you've got the exceptions, which are the ratios without measures, things like pi, square root 2, etc. And then you get into counting, and that gives you the basis for now going from georithmetic into arithmetic. Okay, and in the next lesson, we will see how to perform georithmetic operations with fractions algebraically, that is arithmetic. And so here we begin to show how to do these things. See, using fractions with the same denominator, and then introducing the lowest common multiple, and then finally in the next lesson, which is this one here, and that happens to be lesson 5, we'll be doing dividing fractions. Okay, 1, 2, 3, 4, 5. This one here, and we start looking at the meaning of division, doing examples, and then obviously in the next lesson we'll be looking at more about fractions, and that's this lesson here. And here we see where most of the fraction operations come from in geometry, in the elements of Euclid, how to simplify fractions, what are proper fractions, improper fractions, mixed fractions, quick multiplication, quick division. And in the next lesson, we define a fraction in terms of the abstract unit. That's this guy here, where we talk about modern Greek terminology and how This knowledge was lost by the Greeks throughout the centuries. They just basically retained the superficial stuff. In other words, when I say superficial stuff, um, as an example, it's asking somebody if they know what an arithmetic mean is, and they tell you that the arithmetic mean of 1, 2, and 3 is 2. And it's true because what they've done is they've calculated the arithmetic mean, but they don't understand what the arithmetic mean means. Okay, and it's the same thing with most of the operations in Greek, in Greek mathematics. For example, why do you multiply the numerators and the denominators when you're doing a multiplication problem? So there's a lot of confusion and chaos. Um, and the purpose, oh, this is still in Greek. I have to change that to English. Okay, that's not a problem. So I'll be doing that soon. What does fraction mean? The ancient Greek conception, confusion and chaos, ratios without measure. And in the next lesson, the final lesson, which is the eighth lesson, we see uh, all these problems done and explained by the presenter. So this is coming. I don't know when it'll be done, but I want it done professionally because children have so much problems understanding fractions and dealing with them, and so do educators. Educators have no clue what fractions are. They don't realize that all numbers are fractions and all fractions are numbers. I mean, even the numbers you think of as 1, 2, and 3, right? 1, 2, and 3, they're also fractions. Okay, so that's pretty much what I wanted to talk to you about in this announcement that I'm putting out here. It's going to be a fantastic series in 8 videos, and it's going to come to you in English and Greek. If you're not a real subscriber to my channel, become a subscriber, click like, follow me on Academia.edu, and join the new Calculus Discord to learn about the first rigorous formulation of calculus in human history. Formulation without ill-formed concepts like infinity, infinitesimals, and the circular rot of limit theory. Till next time, I'm John Gabriel, and I'll be chatting with you soon, I hope. Take care.